Hey, boys and girls, happy Monday. I hope that you enjoyed your long weekend in a sense because we know that Friday was our e-learning day. So we're going to get started right away because we need to make up some time to look at some of these calendar markers. Let's look at calendar marker for the 16th. But before you do, make a prediction. I'll give you about 5 seconds. Right? Is that what you were thinking? Money, mat, some kind of shape. All right. Well, then let's look at the 17th. Money again. And let me zoom in so we can really see what's happening. All right. That's the 17th. And then the 18th looks like, what do you think? A mat? Let's see. You're right. And today's date, which is the 19th. What do you think? Another shape. And yes, this time it's the pentagon, but we have another one colored in. So let's talk about these more in depth so that we can fill out our observation chart. All right. We know that when we're working through our observation chart, we're trying to find equivalent names for these pictures. So how could we write it as a fraction? And then what would it look like as a decimal? And then how is that related to money? So let's start with the 16th. All right, so let's start with our fraction for this one. How many, each one is worth how many? Right, a tenth. And how many tenths do we have shaded in? We have 5 1/10 size pieces shaded in, which gives us a tenth plus a tenth plus a tenth plus a tenth plus a tenth, which essentially is 5 tenths. You're right. But just looking at this, what else might you say about this if we were giving it the name or a fraction for a name, a different fraction name, an equivalent fraction name? Yeah, it's 1/2. 1/2 of this shape is shaded in. So how do we write that as a decimal? You got it. 0.5, because that represents 5 tenths. All right, so let's think about 5 tenths in terms of money. How is it like money? Good, it's like having 5 dimes. You're right. Right, and what is 5 dimes worth? Yeah, 50 cents. Good job. Now let's look at the 17th. So here's the picture. It looks like we have a quarter, a dime, a dime, a dime, and a nickel. Let's count that. 25, 35, 45, 55, 60. 60 cents. And so I'm going to write it just like that in our money notation. Right, how would I write that as a fraction? Think about those fraction or those money pieces that we put on top of that dollar bill. 60 cents is like having 6 dimes, and we know a dime is worth a tenth of a dollar. So then I would have 6 tenths of a dollar, which is the same thing as 60 cents out of the 100 cents that it takes to make a full dollar. Okay, so how would I write that as a fraction, a decimal? 0.6 for 6 tenths, or, right, for 60 hundredths. All right, okay, let's do the 18th. You guys are doing really well. So we have 2 more to go. How many of these columns or tenths are shaded in? Yeah, 6 of them, which would give me 6 tenths. And how many are in a tenth? So if I were looking at these little squares, how many of these little squares are shaded in? There are 10 small squares in each tenth. We have 6 of them. Right, so it would be 60 hundredths. Let's write that as a decimal. We know how to do that by now, right? We can do that really quickly. Think about how is that related to money. Good. It's like having 60 cents. Right, because 60 cents out of $1. All right, last one. The 19th, today's date. We have a pentagon. And how many of these are shaded in? Each one is worth what fraction? Right, a fifth. So we have 3 1/5 size pieces, which gives us 3/5. Let me make that bigger. 3/5. Y'all remember what that would be if I were to use tenths as my denominator? Think about it like we were cutting each of these fifths in half. So now we have 10 total. So then how many tenths would I have? Right, 6/10. And maybe that'll help us figure out how this is related to money. Because each fifth would be like, how many cents? 20 cents, 20, 40, 60 cents. And if I had split it and made them into tenths, that means 10 plus 10 is still 20 cents in each of those 1/5 size pieces. So I'm going to write that. It's like having 60 cents because each shaded region is worth 20 cents. All right. All right. So then how do we write that as a decimal? Good. 6/10. You got it. Now, let's play our race to the millions. You guys know that this game changes so quickly. At one point, we were tied. Well, not tied, but we were really close, like 30-something thousand and 40-something thousand. But you guys spun like a really large number. And you put it in the largest place value. And Miss Trammell seems to keep getting the really small numbers that she's putting in the smaller place values, which means you guys are winning. So let's see where we stand right now. You have 944,310. So it is my turn to spin. Here we go. Yes! Finally, I got a large digit. Yes, I got a 9. Guess where I'm going to put that 9? You got it. In the hundred thousands place. Because I'm saving my largest numbers for my largest place values. And the smallest numbers for my smaller place values. And you guys also used your 100,000s. See how quickly this game turns around? Oh, yeah. So I had 36,220. Now I am adding 900,000. And so I get 936,220. Now we have a game going on. That's exciting. So we can compare these two numbers and which one is bigger. Yeah, so you guys are still winning, but I just want to note that I have caught up. In one turn, I caught up with you guys. That's pretty cool. I do have a question though, I wonder. We know that we want to keep the really small numbers for our smaller place values and the bigger numbers for our bigger place values. What about those numbers in between, like 3 to 6? Is it easy to decide where you might want to put those numbers? What place you might want to put those numbers in? Yeah, those numbers can be a little more tricky. But one thing is to help us is we look at what place values we have left. So Ms. Trammell used both her tens place, so she can't use tens anymore. You guys have a tens, you have a hundreds, and so do I. We both have 1,000. I have a 10,000. And we both have another 100,000. So I wonder who's going to win the game. All right, so I have a story for you. And because we're going to talk about reading and writing large numbers today. Okay, so here's my story. Dinosaurs fascinate scientists and other people as well, like my son. I have a 2-year-old and he loves dinosaurs. Because they're extinct, scientists have to rely on fossils and other evidence to learn more about them. Scientists estimate that dinosaurs died about, let me show you the number. They think they died about 65,500,000 years ago. It's hard for scientists to get more specific than that, but 65,500,000 is a good round number to approximate when dinosaurs died out. Okay, so I'm going to write, this number is written for you so you can see it. I'm going to say it again, 65,500,000, right? Now, I want you to think that maybe scientists were able to come up with a more precise way to determine when dinosaurs became extinct, because this is a round number. So it's just an approximate time of when we think they may have died. Okay, I'm going to show you a number. That could possibly be it. Ready? Here it is, yeah. Now I want you guys to help me label the parts of this number so that it looks something like this. All right, so I want it to look something like this. I know you guys have done something similar in previous grade levels where you figured out what place value it's in. It's kind of like in each set of 3 digits, kind of like in a family, because when we say their names with the same last name. And I'll give you an example of that as we talk about this number. So if I were to just show this number right here, just the 4, I could do that using, let's just say, base 10 blocks. And what label would I give that? If I just showed 4 base 10 blocks, I would say I have 4 what? Yeah, that I would have 4 units, okay? And if you didn't know that, now you know. I have 4 units if I were just representing the number 4. So I'm going to put that here. Now, let's imagine I had 7. I forgot about the rest of these numbers, so let me put a shade right here. Sorry guys, my computer is not cooperating. All right, so here's my shade. Let's say I just had this number. What place is the 7 in? Yeah, it's in the thousands place. Right. So how would I say that number? 7,284. You're right. Now, do I say 7,284 units? No, I just say 7,284. So I'm going to actually cross out units because that's just understood. We know that we're talking in terms of ones when we end that number. But we definitely say thousands, and that's indicated by this comma that we have right here. Okay, so what if I just had then this number? What place is that 5 in? Not the thousands, but the millions. You got it. It's in the millions place. And so just like before, if I want to say a number, and I want to use their last name because they're in a family, so these 3 numbers are in the thousands family. These 3 are in the units, but we really don't say that because it's understood. This number is in the millions family, so if I were to say it, I'd have to say 5 million. Got it? So let's try to say this whole number. You try. Yeah, 5,537,284. You got it. So then how do I say this number? Should be easy, right? Well, just for some more practice, before we get there. So we knew 7 was in the thousands place, so this was 7,284. What if I had just that? Good, it would be 37,284. So what if I have this? Right, we didn't move to the next family yet, so it'll be 537,284. So now, try this number. Good, 65,537,284. So now I want to write this number in words. See if we can do it. Just like I'm saying it, I want to write it. So here we go. How do we say this part? Right, this was 65. What family is it in? 65 what? Million. 65 million, and we're going to still put our comma there just like it is in our number. All right, what's the next set? 537,000. Yeah. Good. Another comma. And then what? 284. Right, awesome job. All right, great. We're going to do one last thing. We're going to write this number in a different form. Expanded form. Do you know what that means? It means I'm going to represent the value of each digit, and I'm going to write it in like I'm writing an equation. So let's try it. What is the value of the 6 in 65 million? Yeah, so really it's 60 million. Okay, and what else? What's that 5 worth? And that's 5 million. Okay, let's keep going. What's this 5 worth? What place is it in? The 100,000s place, which means it's 500,000. Okay. 3 is in the 10,000s place, so that means I have 3 10,000s, which is 30,000. Okay. 7 is worth 7,000. 2 is worth 200. We're almost there. 8 is worth 80, and just 4. Yes, and guess what all of that makes up? It makes the number 65,537,284. Now you try saying it again. 65,537,284. You got it. Guess what? Today, we looked at our calendar grid, yes, but we also did some more math. You guys just helped me read a number, write the number using words. We said the number in 3 different ways. We used numbers. We wrote it, and we talked about it or thought about it in expanded form. So good job. If you have questions about how to write these numbers in these different forms, so numeral form, word form, and then we have expanded form, then you need to reach out to your teachers so that you guys can do more practice with some other numbers, okay? The next time we do a calendar collector activity, specifically, we do have a workbook page where we will answer some questions using one of these 3 ways of writing a number. Great job today. Again, I hope you had a great weekend, and I hope you have a great Monday. I'll see you tomorrow. Bye.